and in that we will write this logic. We will understand this after your day 2 course, how to write these things and how to write everything. So for now you can say it is a logic. So for syntax we will say it is a logic. So here we will have our logic. So after synthesis, this will look like this gate. So it will have proper a and b function, and we will have y as output. So for syntax you can understand here is let me change the color. Okay, so syntax you can see this is our main cover module and module, and it is having a static nature, means our hardware will be throughout the simulation, because it should be throughout the simulation. You have to write a name of a gate. So this box you will call and gate. This is the name of this block, and after that you will have a ports. You can write whatever sequence you need to write, like first write input or output, anything, and describe its input, output, and in output is also there if you need. And here it is called a continuous assignment. It is also a block, you can say, and y is output and a and b as a output. So for now we haven't used data types. We will come it in this after the slides. Okay, so for now you have understand that a module and module is, you can say, a layer of a box. In that we will describe input and output. This is our basic syntax. Now data types. So in Verilog we are not limited to 0 and 1, because it is software related language, and software only considers 0 and 1 because it doesn't have to have a physical or environmental thing interfering with your process. So the software will only have 0 and 1, but in 0 and 1 is the two-state data types. So the variable which have two values like 0 and 1 only, they will have a two-state data types. But in hardware we have four-state data type, which will have 0, 1 as well as x and z. So this x and z, x is also known as unknown, and this is z, which will be known as high impedance in our language. So as you know, impedance is very high resistance, and unknown is you don't know whether it is 0 and 1. So here we are not using this x as don't care. This is our digital thing in K-map. Don't care is like we don't care 0 and 1 are there. Unknown is like we don't know what is 0 or 1 are there. So these two things are different. So for Verilog language we will stick to our unknown thing. So what is that? Four-state data we will know. Okay, so why do we need four-state data type? So this is our question. Why we introduce four-state data type? So because in real hardware not everything is always 0 1. As I said earlier, if you are creating a real hardware, you have to be ready for a sequence where you don't know the value of 0 or 1, or there is some short circuit in your circuit. For example, this is your circuit A and B. So either A 0 or it will be unknown, but this will have our problem, like where we will know that this is a short circuit, open circuit. How we will know this is an open circuit? So we need some variable to show this. We will use that z. It is high impedance, that it is not connected. Or what happens if there is two wire, and here it is 0 and here it is 1? So what will be the value of here? Let's say it is A, it is B, and here it is Y. So what is the value of Y? So here we will use X as unknown.